Snapping a photo of the entire Milky Way might sound like a no-brainer, but it's actually impossible. The catch? We're stuck inside the galaxy, tangled up in its spiral arms with no way to step back and take in the full view. And even if we could send a probe far enough out, the distance is insane. Our galaxy stretches over 100,000 light-years. It'd take billions of years just to reach a spot where we could get that perfect shot. Since photographing the whole Milky Way in one go isn't happening, astronomers have a workaround. They map it out piece by piece. Using high-powered telescopes, they track millions of stars and cosmic objects, then patch everything together into the most precise model of our galaxy possible. And that's exactly what you're looking at right now. This is the sharpest map of the Milky Way ever made, built from a jaw-dropping 3 trillion observations of 2 billion cosmic objects over 11 years. It's the crowning achievement of the European Space Agency's Gaia mission. For the past decade, Gaia's been scanning the skies non-stop, and the payoff is mind-blowing, giving us both face-on and edge-on views of our galaxy in crazy detail. But Gaia didn't just map the stars, it unearthed Milky Way secrets we never saw coming. Gaia might not be a household name like Hubble or the James Webb Space Telescope, but in astrophysics circles it's been a game-changer. Scientists say its impact has been like a tsunami, rewriting the book on our galaxy's structure, makeup, and evolution. But Gaia's story goes back even further. It built on the legacy of the Hipparcos mission, which kicked off space-based star mapping. Hipparcos charted 120,000 stars, a huge deal back then. Gaia? It blew that out of the water, aiming to track nearly 1 billion stars, about 1% of the Milky Way's total. Launched in December 2013 with a $1 billion price tag, Gaia made its way to the Earth-Sun L2 Lagrange point, 1 million miles from Earth, same neighborhood as the James Webb Space Telescope. But what really makes it special? The insane precision of its measurements. Gaia can nail down star position so accurately it's like measuring the width of a human hair from 600 miles away. Gaia isn't just another space telescope. It's a next-level engineering marvel built to map the Milky Way with unmatched detail. But how does it actually pull this off? Here's the breakdown. At its core, Gaia packs 2 identical telescopes, set at a 106.5-degree angle from each other. This slick setup lets each star get observed twice as the spacecraft slowly rotates, scooping up light from different cosmic objects. A high-tech mirror system then funnels that light into Gaia's camera, the most advanced ever launched into space, packing 106 charge-coupled devices and close to 1 billion pixels. Here's how it goes down. When stars drift into Gaia's sights, they first hit the astrometric CCDs, which lock in their exact positions and track even the tiniest shifts over time. By checking a star repeatedly, Gaia picks up its parallax, that slight wobble caused by Earth's orbit, letting astronomers pin down its distance with crazy accuracy. Next up, the stars move to the photometric CCDs, where prisms split their light into different wavelengths. Crunching this data, Gaia figures out a star's brightness, temperature, size, and even what it's made of. Finally, some stars hit the radial velocity spectrometer, which spreads their light into a full spectrum. This shows whether a star is hauling toward us or booking it away thanks to the Doppler effect, a key tool for decoding the Milky Way's motion and evolution. Unlike regular telescopes that zero in on one target at a time, Gaia keeps spinning non-stop, sweeping its scopes across the heavens in a carefully choreographed dance. This way, every star gets checked out multiple times from different angles, building up an insanely precise 3D map of our galaxy. The stats will blow your mind. Gaia clocks over 2 million stars every hour, cranking out more than 50 gigabytes of fresh data daily. But Gaia's maps aren't just fancy space snapshots. They show the Milky Way in motion like never before. Every star's got its own road trip across the cosmos, what astronomers call proper motion. By tracking these movements, we can hit rewind or fast forward, watching the whole galaxy spring to life as stars drift, swirl, and transform. Even constellations, those seemingly permanent fixtures in our night sky, slowly morph over thousands of years right before our eyes. Here's the kicker. Stars aren't just moving on their own. Their apparent motion also gets warped by our sun's epic cruise through the Milky Way. When Gaia averages out star movements within 1,000 parsecs of our solar system, it reveals something wild: our sun's grand orbital path around the entire galaxy. And here's where it gets really wild. By smashing together Gaia's pinpoint-accurate star distances, radial velocities, and proper motion data, we can build mind-blowing 3D animations showing how stars actually cruise through space. Check this out. 74,000 nearby stars within 100 parsecs of our sun. Some are drifting inward while others are booking it toward the galactic suburbs. Most stick to chill, circular orbits along the galactic plane, those purple ones. But a few rebels dip above and below the disk, those fiery yellow and red strays. This is how Gaia has handed us the sharpest, most jaw-dropping view of our galaxy ever, completely rewriting what we thought we knew about the Milky Way. Over the past decade, its discoveries have proven our galaxy is way more complicated than we ever dreamed. For ages, astronomers swore the Milky Way just had two main spiral arms with some smaller sidekicks. But Gaia's data tells a whole different story, confirming there are actually more spiral arms, though they're fainter and more tangled than the old models predicted. That face-on view of the Milky Way? Absolute fire. It's like looking down on our galaxy from the ultimate VIP suite, showing off its full swagger. A glowing golden core sits center stage like a cosmic spotlight, while those sleek spiral arms stretch out in a near-perfect space whirlpool. Flip to the edge-on view and it's even more dramatic against that void black backdrop. That slim, coffee-colored disc cuts across the frame with just a hint of curve. Thanks to Gaia, we now know this disc isn't flat, it's got a serious warp. But wait, there's more. This warp isn't frozen in place, it's got moves like a wobbly, spinning top. And here's the real head-scratcher. It's wobbling way faster than it should, hinting that some cosmic undercurrents are yanking our galaxy around in ways we still can't fully explain. One of the weirdest finds from the Gaia mission? The Radcliffe Wave, a ginormous snaking gas structure stretching 9,000 light-years through our galaxy. This cosmic roller coaster makes up 40% of the Orion Arm, our solar system's galactic neighborhood, sitting anywhere from 400 to 5,000 light-years away. Before Gaia's ultra-precise 3D maps, this thing was completely invisible, just looked like random star-forming regions scattered across space. Now we know the Radcliffe Wave is the biggest connected gas structure in the Milky Way, packing 3 million suns worth of material. It's basically the star-making factory for our corner of the galaxy. Here's the crazy part. Our sun gets within 500 light years of this thing at closest approach, like we're catching a cosmic wave. Computer models show we actually plowed through it 13 million years ago and will keep crossing paths in the future. So what created this galactic ripple? Scientists are still scratching their heads. The leading theory? Some intergalactic fender bender, maybe a dwarf galaxy sideswiping us, could have sent shockwaves through the gas. But we'll need more Gaia data to crack this space mystery. Gaia's also uncovered evidence that a galactic smash-up might have jump-started our solar system's formation. It's even helped us track the Sagittarius dwarf galaxy, that pesky little neighbor that's been bumping into the Milky Way for billions of years like some cosmic pinball. Discovered back in the 90s, Sagittarius is a lightweight compared to the Milky Way. Just a few tens of millions of stars versus our galaxy's hundreds of billions. As the Milky Way's gravity yanked it in, Sagittarius started plowing through our galactic disk at least 3 major times around 6, 2, and 1 billion years ago. Each smash-up left Sagittarius more gutted, with our galaxy stealing its stars until eventually it'll be completely devoured. But don't let its size fool you. This cosmic underdog has reshaped our galaxy big time. A 2020 study revealed each collision set off star-making shockwaves like tossing a boulder into a pond. These cosmic ripples squeezed gas and dust so tight they sparked stellar baby booms. Mind-blowing fact, one of these collisions hit around 4.7 billion years ago, right when our sun and solar system were getting their start. A 2019 study uncovered another bombshell. Before these impacts, our galaxy's star production was fizzling out. Then 5 billion years ago, bam! Star formation went into overdrive. Nearly half the stars in our Milky Way's main disk were born during this cosmic renaissance. Translation: without Sagittarius playing bumper cars with our galaxy, the Milky Way would be way dimmer and emptier. Thanks to Gaia's pinpoint data, we've got the full backstory on how even small-time cosmic players can reshape entire galaxies. But Gaia's not just about mapping our neighborhood. It's revolutionizing astronomy across the board. Its data has tracked 150,000 plus asteroids, giving us an X-ray view of our solar system's moving parts. Spotted hidden black holes lurking in our galaxy. Helped bag distant exoplanets orbiting far-off stars. This space observatory is the gift that keeps on giving, uncovering cosmic secrets we didn't even know to look for. This eye-popping graphic shows the wild orbits of these space rocks, from Mercury's backyard all the way out to Jupiter's Trojan asteroid entourage. The color code tells the story. Sun, that fiery yellow dot, inner solar system, cool blue, asteroid belt, Mars-Jupiter highway in green. Jupiter's Trojan gang, red-hot Gaias, pulled off some next-level detective work spotting what looked like 350-plus asteroids with moons. We're talking full-on binary asteroid systems. How? By catching their telltale wobble as they cruise through space. Regular asteroids move smooth, but these bad boys zigzag like they're dodging traffic. Dead giveaway they've got a moon in tow. The spacecraft's insanely precise tracking has also outed sleeping black holes. Cosmic ninjas that don't glow like their matter-gobbling cousins. These stealthy voids were completely invisible until Gaia noticed stars doing the cosmic cha-cha. Their weird wobbles betraying an unseen heavyweight partner. So far, we've bagged 3. Gaia BH1, BH2, and the new heavyweight champ BH3. A 33 solar mass monster in Aquila, just 2,000 light-years away. That's now the biggest stellar black hole we found in our galaxy. But wait, there's more. Gaia recently scored two cosmic oddballs. Gaia 4b, a super Jupiter, 12x Jupiter's mass, orbiting a tiny star 244 light-years out. Gaia 5b, a brown dwarf cozying up to another lightweight star 134 light-years away. This is huge because it's the first time we found planets purely by their gravitational handshake with their host stars. Both break the mold. Giant planets orbiting puny stars is like finding a Great Dane living in a doghouse. Even after all these wins, the Milky Way's still full of secrets. Though Gaia's done scanning, the data gold rush is just heating up, with two mega releases coming, 2026 and 2030. These will supercharge our galactic map with even sharper details about how our cosmic home ticks. As scientists keep mining Gaia's data motherlode, we're getting the clearest picture ever of our galaxy, bringing us closer to cracking the code of this 100 billion star metropolis we call home.